Been doing it for about 12 or 13 years now. I maintain something like 75 libraries and projects, or not all at once, but one time or another. So I've interacted with a lot of people. I talk at a lot of conferences. I have to deal with a lot of bug reports and so on and so forth. And I've learned quite a bit about miscommunication. Specifically the way that geeks miscommunicate. Because I am one, I used to be very, very bad at it. I used to be very socially maladjusted.
It's muted now. If you press mute once, it goes green, then it's active.
Okay. There you are. I think, yeah, here. You get to run around for the left side of the room, and you get to run around for the right side of the room. So that the folks in London can hear us. Yeah, so we're going to talk about how geeks lie. And the interesting thing is that we don't, technically. We love the truth. Oh boy, do we love spouting out truth. Because you're being technically correct is the best kind of correct. Right? And despite what the International League of Pedants says, we value, instead of accuracy over tact, we value precision over accuracy. Now, precision versus accuracy comes from target shooting, which I guess in this country a lot of people would know about. They're very, very different things. So if you're shooting at a target and you go bang, 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 this is actually accurate because you hit the target. You're not very repeatable, though, but you achieved your goal, the bad guy is dead. On the other hand, precision is bang, 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 a very precise grouping of hits. It shows great mastery with your weapon. But you missed. Your goal is not achieved, and the bad guy gets you, gets away, you've been mugged, whatever. Your country is overrun. Precision is about your grouping, and accuracy is about how close you are to your target. If you're inaccurate but imprecise, you can still hit the target. And once you're accurate, you can start increasing precision, and that will help. But no amount of extra precision will fix inaccuracy. But we seem to think it will. That's the geek's go-to thing, increase precision. So what do we mean by lie? Now, there's a difference between what is said and what is heard. If there's a difference, then if it's a big difference, then there is a lie. You might not mean it, but the lie is there. And when you do it, first it's kind of innocent. We really don't mean to lie to people. We actually really, really want to convey the truth. And we're just kind of being ourselves. But you do it long enough, and it becomes pathological. And if you try to ignore it and say, well, I'm just speaking true statements and everybody else is messing it up, and you pretend there's nothing to be done about it, it's just the way that I am, and everybody else is stupid, it becomes a conscious choice to miscommunicate, and then it becomes a lie. And the truth may be absolute, and Godel may say otherwise, but meaning is very, very subjective. And that's where the lie slips in. It's meaning that counts in communication. And we have to translate our truth into language, out the mouth, transmit it to another human, who then translates that back into an idea, which may or may not be the original idea, because human language is very, very imprecise. Question: how many people here will raise their hand? Jesus. Well, thank you. Thank you, London. All right, well, maybe I shouldn't ask too many audience polls then. I noticed in the library that there's a LodgeBand book. I mean, how many people here dabble in LodgeBand? Or if I may not even be pronouncing it right. The logic language? Yeah? Anybody? Raise your hands. Okay, well, every other language is imprecise. And nobody speaks LodgeBand. Any LodgeBand speakers in London? No? Okay. So why is this important? Well, at the extreme end, lying like a geek might get you killed. So the original geek, Socrates, thinks that it's enough to just speak the truth. And he doesn't believe in rhetoric, the rhetoric being the art of elegant composition and communication. He doesn't believe this is useful. He believes this is papering over the truth. The truth will be enough. Nobody listens to him eventually because he talks down to his audience. He winds up literally sock puppeting his opponent. At the end of Plato's Gorgias, you can find where he actually, with his opponent is so exasperated with Socrates that he says, I just can't talk to you anymore. Socrates goes, oh, fine. Do you mind if I just do your side of the argument for you? He's like, fine, yeah, whatever, go away. And so nobody's actually listening to him anymore. And it's okay, you're not wrong, you're just an asshole. And nobody wants to listen to an asshole. And what I like to call this, Socrates may be the first one, is literalist fuckhead mode, where essentially you have just basically gone into a point where you're taking everything deliberately, literally, possibly the most annoying way possible, and no longer caring about what your audience is hearing or actually trying to get the point across to the audience. You're now just trolling. Socrates basically pisses the wrong person off. He's arrested for corrupting the youth of Athens. And on trial, he talks down to his accusers, likening them to children. This is not very persuasive, and he has poured the worst mixed drink in history. So, yeah. Moving on from that, let's look in some ways at Geeks Lie. The first lie is, of course, the presenter lie. No matter how many times I give this talk, I always have to revise it. Lies by design. Whether or not we admit it, every software engineer in here is a designer of some sort. Software is very hard to use, and there's a lot of reasons for this, and some of which we tell ourselves, but there are lies. Software does not necessarily have to be hard, it's just a bit more difficult than traditional interfaces. The first biggest lie is the users are idiots. Users are not idiots. They just don't necessarily know what we know. It's something that you learn in kindergarten. People don't know what's in your head, but we sometimes pretend like they do. The other lie is, it was complicated to build, so it must be complicated to use. It's an actual functioning urinal in Portland. All the dials and gauges actually work and show pressure as stuff goes up and down. An additional lie is, well, works on my machine, or better off, I understand it, why don't you? Well, of course you understand it, you wrote it. And to understand why that doesn't work, it's important to know how information flows from the geek to the user. And it looks something like this. A little diagram here, where starting out with the geek, who has some sort of idea in their head about what they want to do, and the geek writes code. And there is a two-way translation between the geek and the code. The geek sees the code and writes the code, and that affects how you think, and vice versa. It's kind of back and forth, back and forth. Now, this code presents some sort of interface to the rest of the world, whether it's an actual API, or if it's a GUI, or if it's a command line prompt, or whatever. There is something that this code will produce whereby a user will use it. If the user is an actual, user using a mouse typing at a keyboard, or user is another programmer, they don't see the code, probably, but they don't see the code, and that's why that one-way arrow comes in. And that is at the point where information flow stops. The user can only interact with the interface. The user cannot interact with the code, and the user can certainly not interact with you. So, what does that mean? That means that the user only has to go on what's in the interface and what their previous experiences are. The user knows nothing about what's in your head. The user knows nothing about what's in the code. And you cannot have a personal conversation with every user, as much as people might try. And one thing that I think you guys know about is scaling. This does not scale. It might scale in an office with 10 people, but it doesn't scale in a Google scale. Well, so what do you have? It means that, if all the user has is the interface and the previous experiences, and you can't affect their previous experiences, all you've got is the interface. That's the only way you can talk to the user reliably. The interface also includes documentation. It includes function names. It includes variable names. It includes how they work. It includes error messages. It includes traditional GUI and stuff. And this is very, very important to realize. They do not know what you know. Yeah. Any questions on that before I move on? No? Okay. So moving on to the next lie, and this is a similar lie about what we know and what the users don't know. Biggest lie in computing. Computers are good at math. We all know this is a lie. Computers are terrible at math. They're absolutely horrible at math, and we all know it. Why? That. Computers cannot do elementary school fractions. Now, the human looks at the result, and they go, why isn't it printing equal? And they say, wow, that's wrong. That's against everything I've been told in school. It must be a bug. And maybe they report the bug. And maybe they get back a tirade. Probably they get back a tirade about IEEE floating point numbers. And they're generally yelled at and told, read the fact. Why are you talking about this? Oh my God, how can you not know this? When in fact the user is right. This is a bug. We're just so used to it, we're insane. The user's reaction is correct, and we're all delusional. And we're so warped by having used computers for so long, we've forgotten third grade math. And languages, there are certain languages that actually, try and make this work by upgrading or downgrading or whatever else, and hiding this problem. And that means that they're dealing with it instead of at the code or geek level, they're dealing with it at the interface level. And they're acknowledging that users' previous experiences expect this to work. I'm trying to think of a language. Does Ruby do this? Probably. Question? What's that? They deal with fractions quite a lot? Haskell and Lisp, they do that correctly? Cool. So Haskell and Lisp do this correctly. Let's see, moving on. Talked about it. It's a lie. It's a deep design bug. Okay. Next one. Lies by affordances. Anybody here know what an affordance is? Somebody? A few people? Okay. If so, by my control standards, thank you, London. By my control standards, that's 120%. People here know what affordances are. Right, so everybody else, they're the cues that an object give you about what to do with it. By an object, I mean an object, like a table. And this is why every horizontal surface in your home will eventually be covered in crap. And it's also why people do apparently stupid things. I would do this every day when making tea at a particular office because that door was blocking the table behind it, and it was just more convenient. There was a horizontal surface. And this also explains, and of course, doors. If anybody's familiar with Donald Norman, he loves to rail on doors. This was at the San Jose Convention Center. And, do you push it or do you pull it? Well, who knows? It's just a bar. It doesn't tell you anything. You can grab it, and you can push it, and you can grab it, and you can pull it. And worse, it's transparent, so you kind of see what's on the other side. But you feel like an idiot for doing it wrong, right? If you ever walk up to a door that has a grabby handle on it and pull, and it goes pong, you feel stupid, even if it has a label on it. Because you don't read that. The affordance completely overrides anything else that's around. It's the first thing you grab. So if it's simple, and you have to put an instruction on it, something might be wrong. Which in terms of computing software, if you have to write like a whole page of documentation about something, or if users keep reporting the same thing over and over again, and you keep replying back, no, you're using it wrong, no, you're using it wrong, no, you're using it wrong, well, you might have something wrong with your interface, and you may want to change that instead. The affordances in computing are much harder to figure out because we don't have these things kind of hardwired. They're not touchy-grabby, feely things. I don't know if anybody's ever really written a book on this subject. But they're there. For example, how do you shut down a Windows machine? Well, you hit start. And then, sorry, how do you log off of a Windows machine is even better. You hit start, and then you hit shutdown, and then you log off. And this doesn't make any sense. I think 7 fixed this, maybe, but I like to pick on Windows XP. It's fun. Right, moving along. More design things. So the other thing that interface designers talk about are constraints. And a constraint is a limitation on what you can do. And for geeks, this is bad. We want power. We want to be able to do as much as we can. But for interface design, constraints are fantastic. I'll show you why. Here is the most terrifying thing you can show a user. Your typical default Unix command prompt. There are no constraints. Anything is possible. At least it's not a root shell. um, what do you do? What do you do? What do you do next? What do you type in? There's no. I mean, in for the longest time, help didn't even work. When you typed help, you would just get, I don't know what help is. It's very powerful. It's very scary. You can try to do everything, and you can do it, but it's not so much a learning curve as it is scaling a wall. And one misstep, and you can blow away everything permanently. And this is why the desktop metaphor was invented, because we need something to grab onto, something to limit our choices in an unfamiliar environment. And you guys should know about this because you take something like Linux and you put a nice shiny interface over it, and suddenly it's something you can hand to anybody on the street. And yet, it's a nice shiny constrained user interface, and yet the power is still all there underneath. If you want that shell, it's still there. Unlike a certain other phone maker. Right. Another example from Perl is sometimes you have no interface at all. We call these pragmas, and you load them, and they change the way the language works in some very, very well-defined way. In this case, it shuts off a bunch of very, very bad implicit language features. There's no question how to use it. You just turn it on, and that's it. Kind of like a light switch. It does one thing, and it does it really, really, really well. Questions about constraints? Okay. Another lie. Here's another lie. Perl had no Y2K bug. A lot of programming languages had no Y2K bug. Well, technically correct. This is a lie. It was such a lie to the point where Perl had to write a special README to explain why it did not have a Y2K bug, because we were getting so many Y2K bugs reported. And it turns out that if you have to document that a problem is not a problem, you have a problem. To the point where we even had modules to find the Y2K bugs in your Perl code. So if Perl had no Y2K bug, why did it have so much Perl code have Y2K bugs? There was also, because Y2K didn't really happen, there was no disaster, we had un-Y2K to remove all the Y2K fixes. Yeah. It's an April Fool's joke. Why? Because the interface is crap. This is the standard way to get the date and time in a Perl module. And it is horrifying, both because you have to remember, that return value number 4 is the day of the month, but also because the year, C programmers here, what's the year returned as? Yeah. How many people do you expect to know that, especially pro programmers who have never programmed before? Everyone you hire, yes. So back in 1999, you wrote that, and it said that, and it didn't work out as expected. But you thought, well, wow, why does Perl just return the last 2 digits of the year? That seems really silly, but okay, I guess they designed it that way. You're supposed to do this, but they did this because it works. It works, and this action, probably returning the last 2 digits of the year, makes more sense than returning an offset from 1900. That only makes sense if you're an old school C programmer and trying to save a few bytes of memory, a few bits of memory. And now note, which one is easier and more succinct? This one or this one? Which one are users going to write? That one. Yeah, the broken one. But users will go for the easier one every time. And you don't fight it, you will lose. So this is so obviously wrong that people were convinced that this is just what you had to do. Right. This was so prevalent that our year 2000 Perl conference was actually 19100. So Perl doesn't have a Y2K bug, it generates them. And bad interfaces create bugs. They're just bug generators. And even if it's wrong, especially if it's obviously wrong, even if it's wrong with a moment's thought, a lot of people will still use it that way. They'll rationalize it. They'll think that, oh, of course they must have known what they were doing. And for some reason, because I'm not a fancy pants programmer, I'm just somebody that writes web pages, there must be some weird computing reason why they had it. And that's true. There was in 1972. But for some reason, this got held forward. So that's mostly all I'm going to say in interfaces, because there's lots and lots and lots of ways to lie with interfaces. I'll just say to read this book, Design of Everyday Things. It's fantastic. It will open up your eyes. See a lot of people in the audience saying yes. Question?
That book was originally called Philosophy of Everyday Things. If I have to change its name.
The Psychology of Everyday Things. Psychology section. Yes, it was called. Yeah. So for London, it was called the Psychology of Everyday Things, and they kept putting it in the psychology section, and nobody could find it. Yeah, Donald Norman really liked POET as the acronym, much better than DOET. It was also written in the 80s, and he has a chapter on computers, and it's sadly still very, very relevant. The other one that I really like is this, Don't Make Me Think. It's one of the best fundamental web design books. It doesn't contain a single bit of HTML or JavaScript. There's a second edition out, just came out very, very recently. It's a very, very short read, and it pretty much hammers home this idea that if your interface makes the users have to stop and think, it's too hard, and they will make a mistake, and it will be wrong. Again, it's coming from the point of view of web design, but it's also useful for everything else. And these two books are just eye-opening and enlightening. You'll never look at a door the same way again after reading this book. And DOET, in a lot of ways, is therapy for users. And it really teaches the user, no, you're not dumb. And no, interface designers aren't gods. If you can't use a simple thing, the interface designer was wrong. If you can't open a door, then they made the mistake, not you. The user is not an idiot. Right. So, moving on to the next lie. Mostly done with interfaces. Is this wonderful one that we love to do? The means justifying the ends. It's a tendency for geeks to get so wrapped up in the implementation details and what they've created and how it works and how fast it is and how elegant it is that you forget what the end goal was. And you present this thing to the user and they go, I can't use this. What is this? And you go, but it's fast. But it's implemented in, language of the week. It's prioritizing technical or philosophical correctness over getting the job done. Examples are, which there's a lot of Subversion users in here. Subversion for a very long time had the interesting delusion that they were a version file system, not a version control system. And this philosophical rift meant that they didn't actually implement a lot of features to actually use it as a version control system. Git has the same kind of thing. We're a content management system. We're not a version control system, whatever. And they're finally figuring that out after a few versions and a few interface people getting involved. Perl, get back on Perl, we could not decide on a wiki to use because most of the good wikis are not written in Perl. And we refused to use MediaWiki because that was written in PHP. But it's what everybody knew. And and there's still no good Perl wiki. The existing Perl wiki is overrun with spam because it's just not very good. A wonderful example, I hear there's some Python programmers in the audience. I love to rail on this one. You pull up the Python REPL, and it says, oh, type help or copyright or credits or license for more information. Okay, I'll type in license. Oh, no. You're supposed to type in license parenthesis to see the full license text. Even their own documentation is lying. All right, well, that didn't work. Help. Oh, no. Type help parenthesis for documentation. Or type help object for help about object. Now, if I'm typing help in a Python prompt, or any programming language's prompt, I probably don't know what the hell you mean by object. I'm a programmer, I don't know what to put in there. Topic, keyword, whatever else, that is technically correct. Technically correct that you're putting help about an object in there, because this is a REPL. This is actually evaluating Python code. And so before I go on, let me move on to the final whopper, the one that always gets me is this one. Just let me leave the thing. No. I know exactly what you meant to do. But I won't do it, because you didn't do it the one way that you're supposed to do it. God forbid we had two ways of doing the same thing. I've gotten conflicting rationales for why this is so, and I'm curious if anybody in the audience wants to take a stab at it before I tell you why.
You get a reference to the method instead of calling the method?
No. Good try. Anybody else? Anybody, yeah? To be some random variable. I thought about that, but you can still do that without that. You can reassign exit. Anybody else? Yeah. You want people to write help and license in their code? That's interesting. That would probably fly. That's one of the ones that I've heard before. The strongest one I've heard before is that, first you have to realize that these license and help and exit, these are all objects that have been predefined by the REPL, and they're all string overloaded to return annoying help text. Not a helpful help text. Help text telling you that you did it wrong even though you did it exactly the way we told you to do it. And in this case, the license, well, it could have just been string overloaded to return the damn license. Help is actually going to be a function, but it would have been nice if it pulled up an actual help. What was really going on here, and for exit, it's returning an instructions about the exit. What's really going on here is that in order for this to do the right thing, it would mean that that exit object, would have to be string overloaded to have a side effect to exit the REPL. And that's icky. So it makes perfect sense philosophically in cleanliness. If you were doing this in normal code, that would be fantastic. But the point here is not philosophical in code cleanliness. The point here is to give the user help. And this is a command prompt, not a programming environment. It is both, and you might have to make some exceptions for both of them. So I find that one a good example of the means justifying the ends. In the end, doesn't really work for the user. At least they put the help text in. At least they didn't just say nothing. A newbie isn't going to realize any of these things. But once you explain it, once you say these things are objects and this is string overloading and it's kind of nasty to do that, it kind of makes some sense, right? Maybe. And there's sort of a class of lies where it only makes sense if you already know the answer. Even that is still really annoying. But that brings me into the three kinds of interfaces. There are those you can figure out for yourself, like that. Aside from learning some basic symbology, that is common to pretty much everything, and I don't want to hear anybody talking about nipples. You can figure out what you do with that. Here's another one that's pretty easy to figure out, assuming that you understand that print does not spit paper out of the machine. That one's pretty straightforward. The new line's a little, maybe not so much. Those are great. If you're Larry Wall or you're Steve Jobs, then you can do those things. But you probably can't. I can't. They're really difficult to do. Better thing to shoot for is this. Those you can remember after having explained only once. After you had the basic concept explained to you, you go, oh, okay, yeah, I get it. I totally get it. And you remember it every single time thereafter. For example, this. If you hand that to somebody, they go, what do I do? Do I push the buttons? What is this? And you show them, oh, no. Oh, okay, I get it. It's a pattern. And they're done. They pretty much remember it. This, you'll remember it. You might not like it. But, system out, blah, blah, blah. And it's pretty straightforward to remember. Not great, but it's not this. Interfaces you can remember only by rote. You know, I don't think I have a picture of it, but the door handles that you can pull or push. You never really know what's going on. The local time interface I showed you. No pro programmer ever knows what the sixth return value from local time is going to do. They always have to look it up again. My oven. Despite them being clearly labeled, I never remember. I always remember right and left, but I never remember which one is front and rear, because there's no real indication to it, and the positioning is essentially arbitrary. And people have told me that there's some sort of international standard for this.
Yeah, in the book you quote by Donald Norman, one of his students actually gave a beautiful solution for this one. You slightly move the two on top, and then you get a line, and you get a line-to-line mapping, and it just works.
Yeah. I have another talk where I Photoshop this to do exactly that, where one is slightly below the other, or you put them in the middle, or there are all sorts of things you can do to it. And yeah, just to give that small amount of association with the controls and with what they do. But yeah, this I'll never remember this. Was there another comment? Yes, I do. Well, I never actually burned my hand on it because basically all American stoves are not all, but a lot of American stoves are done this way. But yes, the interface where you have to reach over the hot stove in order to turn anything is a little bit kind of a bad idea. Yes, that's a bug generator. That's a hospital bill generator. Good point. Okay, moving on away from interfaces. Let's talk about lies by tactlessness. Kind of like going back to Socrates. If you're tactless, people will get annoyed, and annoyed people don't want to talk to you. They don't want to listen to you. And so the emotional state of the listener is very, very important to getting your point across and their perception of you and your idea that you're trying to tell them. It can change their reception of the message. You have to apply some tact. Now, some guy at MIT, I forget who, unfortunately, wrote a short paper a number of years ago about tact filters. It's like 4 paragraphs, and it's fantastic. It's a very easy way for a geek to think about applying tact to a conversation. Now, normal people, so you can put tact on the input, or you can put tact on the output. And the problem is that geeks use tact differently from other people. Normal people do this. They put tact on the output, and the listener has no input filter. They expect the speaker to be tactful. We do it the other way around. We put tact on the input. We assume that the geek is just saying, being themselves, and then we kind of strip out all of the, I don't know, whatever is said. Or we add in the pleases and thank yous and whatever else, It's just the way, it's just the way he is, just the way that person is. And we expect this. So no tact on the output, tact on the input. People are the other way around. And you see what happens when you get a geek talking to a person. No tact whatsoever. The geek comes off as being extremely rude. But when the inverse happens, when a normal person is talking to a geek, oh, God, why are they being so formal? Just get to the point. Jesus Christ. Why is it all, hi, how are you? What's new? Please, thank you. Ah. Right. So you have to adjust your tact for the audience. And to do this requires some observation about what the accepted level of tact is. And on a mailing list, you might just lurk for a little bit. You might read the archives, see what they're doing. At a party, this is basically conversation surfing or the cocktail party effect. You just sort of, listen to what other people are saying, thinking about it. It takes some work. It takes some training. It's not always obvious to figure out what to do. So I have some helpful defaults. You put a minimum amount of tact on your output. You can't go wrong with a minimal tact filter. Hello, please, thank you. Things that, again, they taught you in kindergarten. For email, minimal tact filter looks like this. Hello, name, pointed by message. Thank you, me. And that'll do it. And even the most tactless geek won't be overwhelmed by this level of verbosity. Um, and a normal person will, think that you're something close to normal. You might throw in a few extra pleases and thank yous. If they did something for you, thank you. If you're asking them to do something, please. Even if it's their job. It. What did I do? It turns out that if you want to be really, really, really valuable, you don't really need to be the best programmer in the world. You just need to be a pretty good programmer that actually can talk to people. At one of my few stints at a full-time office job, I became known as the programmer who would get up and go and walk over and talk with the business guys instead of talking with them over email or talking with them over IM. If it seemed like we were hitting a problem, then I would go and talk to them, and they were frankly amazed. And that got me remembered. It wasn't remembered, I didn't write the best code, but I wrote the code they actually wanted because I talked with them. Which gets into lies by with text. And this is, I think, is the biggest problem with communicating on the internet, is that we use text. And despite this being 2011, most internet communication is still by text. We don't have the Dick Tracy video phone, or we do, but they kind of don't work. And it's efficient, it's low bandwidth, it's out of band, which means you ignore it until you're ready, generally. But there's a big, big, big problem with it, and it's this. Text lacks empathy. And communication is not just about the words. Communication is about the emotions that back them, the inflection, the timing, the facial and body expressions, eye contact, and we just are used to all of this being there, and text strips it all off. And it's all gone. And you have to explicitly put it back. Now, the problem is that we're not trained writers. Trained writers know how to do this. They know how to put the emotions back in. And how many trained writers do we have here? One? Yeah. So they know how to think about their audience, the mindset they're in, everything else. We don't write, we speak with our fingers. Right? Everybody, when they type, you kind of have a voice in your head that's your voice, and you're kind of saying what you're saying. But all of the inflection and emotion and body language and everything is gone. And without realizing it, we can drastically alter the meaning. And very often we don't even know why. We write something that we think is very friendly, and we get fire and brimstone back. Because they don't know how you feel. And when they don't know if you're pissed off or happy or sad or joking. And it turns out that when there is a void, when there's a neutral message, when there's no emotion there, when there's no information, people tend to insert negative information there. If your boss IMs you and says, "I need to see you in my office right now," is that a happy thing? You just assume it's bad. If you get an email from a partner and says, "We need to talk," that's dreadful. So you have to. I guess I did. So you have to state your emotion. You have to put your emotions back into it, or else the listener will put negative ones in instead. If a conversation is going really badly, you don't know why, you state your emotions, you state your assumptions. This is what I think that I said. You state what you're hearing. You can sometimes repeat back to them what you thought they said, how you heard it. It can be as simple as saying, "I'm really pissed off at what you did, or what you said, or this thing makes me really happy," or that. These things are really, really concise and very, very powerful to convey emotions. Yes, I'm happy. Oh, I'm just taking the piss. They're powerful and compact indicators of emotions, emoticons. I like to say they increase the empathic bandwidth. So text has very, very little empathic bandwidth. You have to basically shove things through little drips and drabs at a time. So if a conversation is going badly, you want to switch to a medium that has more empathy, more inherent empathy. That's me as the programmer getting up and going and talking to the business guys, because face-to-face communication has all of the things that we expect implicit, all the emotions we expect in communication. And it looks something like this from least to most. You've got email. Email is terrible. Why? Because it's pure text, and you're writing essays back and forth to each other. It's not real time, and you have all this time to you have to write a huge response to them, and then a huge response back, and a huge response back, with no ability to interject. Right? It's debate club, and it's adversarial, and it's horrible. So you try to. I am an RC. At least have the ability to interject and say, whoa, that's all wrong. I think you've got something wrong here, or little corrections as things are going on. It's more like real conversation. So real time is better than out of band. And then if you can go to voice has all the timing and inflection in it, and voice is pretty good. Talk to people with the telephone. You go to video, you've got faces now. We're hardwired for facial recognition. And then finally, real life is even better than all of them, because even in video or voice, you can't necessarily see what's going on around them. That might be distracting them. It might be taking their attention away. Yeah.
Doesn't that really depend how you're talking to? So if you're talking to someone you already know, it might be a lot more efficient.
Can you handle the microphone? There's a mute button on it. You got to hit.
I think I pressed.
Is it green?
Yeah.
Mm.
So doesn't really the what you're choosing, which level you're choosing, and what's most efficient depend on who you're talking to? So if I talk to someone I already know, often I find I am a lot more efficient than voice or video.
Yeah. If you already know the person, if they have basically your voice in their head as you're talking to them, if you've met them before, or if you have a really, really long relationship with them on IRC or whatever in some other community, then yeah, they're already interpreting, they're already putting in the right emotions back into your text. This is. Yeah, it's not about efficiency of communication. It's about getting the point across. This is why conferences are fantastic, because you have all these people that you only ever see on email, and then you meet them in real life for maybe a few days, and now you have a voice and a face, and you find out, oh, that guy. Well, he's seems like kind of a jerk on the mailing list, but when I had a beer with him, we got along just fine. And now you can give him a little bit more benefit of the doubt. You can say, oh, he's just screwing around with me here. He doesn't actually mean what he's saying, or he's just pushing this point too hard, so I know to tell him to shut up. I found more flame wars are solved by a 5-minute talk, or even 2-minute talk, or 1-minute talk, than any amount of email exchanges back and forth. Yeah.
So there is something.
Press it again. Maybe press another one.
Yeah.
So there is something I don't see in your diagram here. It's a form of text that I use a lot as a programmer. It's documentation. And typically the problem of documentation is that as a programmer, I tend to do it context-free, because I want it to be understood always in the same way, not depending on the mood. Would you suggest that I should make documentation where you say, don't use this function if you're not in a good mood, or, I wrote this class when I was pissed off, something like this?
Well, these are two-way communications. The documentation is a one-way communication. You kind of hit on something with documentation, is that, I don't think I have it in the talk, is that you want to document why do you use a function, not if they're pissed off, there's really nothing you can do about it. The actual tech writer could talk more about this. You want to talk about why you use it and what situations you use it in, as opposed to simply what it does, because that's far more important information that you can't get out of it. As far as emotional state goes, you can basically just assume that the kind of have to assume that the reader is in some ways annoyed with you. If they're reading the documentation, then they probably can't figure something out. I don't know. I never really thought about the emotional state of the reader of the documentation. I've thought about the emotional state of the bug reporter, because they're definitely pissed off. And in that case, documentation in that respect has to be written to that, to basically say, yeah, I know you're pissed off, but let's try and do something useful here. I don't know. I'll think about that. Moving on, because I have about 10 minutes left. I'm going to skip over jargon because you say things that don't make any sense. All right, let's talk about this. Lies by too much information. Oh boy, do we love to do this one. Something I like to tell more vociferous geeks. Not everything that comes to mind needs to come out the mouth. You can literally, basically, I know people have this like, I have to say it, I have to say it, I have to say it. I literally had in one talk that was a complete disaster. One guy in the front row, a friend of mine, that I had had some vague technical thing on the slide that was making a totally different point, and he just had to get out, like I made some mistake on it that was irrelevant to the point, but he just had to say it. That he just basically started talking and talking and talking and talking and talking. I'm literally sitting there, like staring at him, going, Matt. He just couldn't stop himself. You can sometimes have to stop and count to 5 and think, okay, is this important to the conversation? Does this information actually help? Does this information actually really add anything to what we're actually talking about, as opposed to simply the general knowledge of the world? Because we're not all, verbal Wikipedia. Another thing is to kind of speak like you tweet if you do Twitter. Think of it in terms of like, well, I have 2 sentences to convey this information. What can I chop it down to? What's important? And that's really interesting. We have one of the programmers in the client that I'm at, we're considering putting on a word diet. He said he speaks so fast because verbal communication simply doesn't have high enough bandwidth to communicate what he needs to communicate. There are lies by information overload. Basically just telling somebody too much information so that they zone out and don't know what's the important bit. And geeks tend to basically go detail, and kind of skip over the summary. And when you're talking to somebody, you have to start with the summary, the executive summary, why this is important, what's the takeaway here. And then you can talk about why, and the why this is important, why you should be listening to me. And then you put the detail last, if at all. At this point, if you're talking to an executive or somebody doesn't need to know the details, they can decide to tune out and the conversation, whatever else. By putting in this order, you allow the listener to choose how much they want to hear, as opposed to if you just all detail first, then they're kind of waiting for the payoff, waiting, what's the point? And many people are not pushy Americans, so they can't just say, get to the point, right? Yeah, so you got to get to the point before your audience is completely and totally bored and tunes out. So we have lies by stating the obvious. This is a bit more rare, but I've seen it enough that I think it's worth mentioning. Some people will state something that is obvious. That let me think of a good example. Right, there was in Perl, somebody proposed a feature change, and we were talking about it. And one of the devs kept saying, "Remember to change the tests. Remember to change the tests." And every time we would talk about it, he'd pipe in, "Remember to change the test. Remember to change the test." And finally, we said, "What's so important about the tests on this change? What do you?" He's like, "Oh, I just wanted to let you all know that you have to remember to change tests." Something we do on every change. There was nothing special about this, but we were all wound up. Like, what is so weird about the tests on this change? Another one is that this came from my father, who is not a geek, but he had some fancy new television, and he kept asking me that before I'd seen it or ever touched it, like, do you know how to use the TV? Do you know how to turn it on? And you know how to do that? I'm like, I guess so. I don't know. And I'm expecting that it's one of those old styles where you have to like turn on the VCR and set the channel 3 and turn on the TV and switch it to AUX 2 and then whatever else. And no, it's just like one remote and I click on. You just like basically what he meant was, have you seen my fancy new TV? But I thought that there was something going on. Right. So another lie is lies by misunderstanding your audience, and this one is far more common. One of the examples I have here is my housemate is a wind turbine engineer, fresh out of school. He gets to abseil down wind turbines. It's pretty amazing for a first job. But he's learning SQL to do some statistics about turbine maintenance, about basically which turbines are costing them too much money and which are problematic. He's never done any other programming whatsoever. He has no programming background. He plays video games on computers and edits documents, and that's about it. And he was asking at a party if he should be learning SQL. Is this a good thing? Is this something I should know? Is this going to be useful for my career? And my answer was, yeah, absolutely. This is going to be useful for you through your entire computing career. And one of my friends in high performance computing said, no, you should learn R. Because it's much better at statistical analysis and blah, blah, blah. And he was very, very confused. So the audience was not, he was not speaking for his audience, or his realizing this is somebody who is a newbie, has no idea what he's talking about, has no way to choose one language or another. And then yes, SQL is fine. Maybe if after a year or two, you can start thinking about learning R. Another example, I'm on Stack Overflow a lot. A lot of times you get people asking, how do I parse this HTML with a regex? And people will answer, I'm like, well, here's your regex, and that's technically correct. But the user asked the wrong question. They don't realize that searching HTML with a regex is a bad idea. There's lots of corner cases, and that it'll just eventually go wrong, usually pretty darn quickly. And simply answering the wrong question without further discussion is a lie when you know it's the wrong question. And these people know it's the wrong question. He got like 3 or 4 answers, all with regular expressions, with nobody actually saying, no, you have to use an HTML parser. Sometimes you have to answer a question by correcting the question itself. But it doesn't end there. So I gave a pretty definitive answer saying, no, you have to use an HTML parser, here's why, and here's the instructions, and blah, blah, blah. But one of the commenters didn't like that. He didn't like how absolute my answer was. I was technically incorrect. And wanted to talk about how, yes, there are some edge cases in general in open and HTML. We know enough about blah, blah. There are discrete and well accounted for HTML snippets where it's perfectly reasonable and preferred to use a regular expression. Yeah, this is a discussion that will only confuse the original poster.
So much of that going on, email threads with Google and drives me nuts.
Yeah, people wanting to technically correct the conversation. Yeah, this adds nothing to the discussion. It just confuses the original poster. And yes, I do know enough about the original poster to know that he will not understand this. Is not at that level. School teachers know this. You teach by a series of carefully constructed white lies and omissions and simplifications, because if you just vomit the entire subject at them, then they won't learn it. And my response was simply this. I totally agree with you. He's not ready for it. See, I've got about another 5 minutes, if that. Let's see. Okay. This one's very, very important, and this is kind of an opposite lie. When asked a question, a geek will usually try their best to answer it, even if they don't really know. They'll try and ask it, make something up and think, oh, well, I guess if, this could be this, and try and kind of work it out from first principles or whatever, without often saying that that's what they're doing. And this is here's a very, very important phrase if you ever want to convey information, or if you want to learn something. It's this. I don't know. Pretending you're an expert by making something up, you might not necessarily what you're doing. You just want to kind of puzzle out the problem, right? We're not really trying to pretend like we know stuff. It's just a puzzle to figure out. If somebody says, why is this thing? And you say, I don't know. And now maybe they might know, and they might tell you. You might learn something. It is a fantastic way to learn things, by saying, I don't know. And to say it to people outside your field, to say it to accountants, to say it to your janitor, to say it to all the people, Not necessarily I don't know, but, what do you do? I have no idea what you do. It's kind of fascinating to say this to people who do jobs around you that you would traditionally think are require less education. Go talk to your accounting department. It's fascinating, the stuff that they do. That you do not know, and sometimes you don't know, even know that you don't know. It can lead you down all sorts of roads of discovery that you have no idea that they even exist. Oh God, I'm really running out of time. So I just want to get through this last thing, talk about lies. We talk about lies, talk about geek lies, and statistics. I'm going to have to zip through this really fast. Right, so this came out of statistics from Google Code. There's 34 million lines more of PHP than Perl in Google Code. Well, that's what was said. What was heard was, there's a lot more PHP than Perl. And looking at it visually, what you see in your mind, 34 million, holy crap, that's like this, right? Yeah. Because there's no scale on this axis. What if is the scale like that? Does that mean, this is basically, that's what that visual representation of what was heard is that. So if you add the scale back in, at least now you can see that it's a truncated graph. This might be a more true graph, and now it doesn't look quite so huge an impact. Yeah, that's the only point about that. I'm going to skip this. Same kind of point. Right. I had this whole rant about the TIOBE Community Programming Index. This is a huge lie. If anybody's familiar with TIOBE, they basically, oh hell, I'll skip it, it's too much. They basically make this assumption that the popularity of a programming language is associated with how many hits they get on, Perl programming, Java programming, Python programming. But the problem is that they actually make too many. Yeah, the ratings are based on the number of skilled engineers worldwide, courses, and third-party vendors, which is an enormous lie. They're really doing this. Yeah, it's a pretty damn big lie. It's right on their front page. It's right in all of their methodologies. It's an extremely dangerous lie because what they suggest you do with it is to check whether your programming skills are up to date and what programming language should be adopted when starting to build new software, based on supposedly the number of engineers worldwide, but actually based on hits on a search engine. And the assumptions there are that the number of that there's actually the same relationship between the programming language and number of hits on the web and blah blah blah. Right, people with statistics lie. There is a fantastic book on the subject, How to Lie with Statistics. Again, it's very, very short and small. I really suggest you read it. It's another one of those books that will change the way that you look at the world, particularly advertising and newspaper articles and stuff like that. It was written over 50 years ago, and it's completely and totally irrelevant because we are terrible at statistics. The average person is terrible at statistics. People who use statistics are fantastic at it and know how to manipulate them, or they're really terrible at them and just simply get it all wrong. I highly recommend that you read it. Now my hour is up. I have plenty more material if people want to hang around. I will gladly talk. So if anybody has any questions they want to ask before they leave, you can ask them now, and I don't mind if people need to take off. But I will keep on going if people want to stay, but I won't feel bad if you want to go. Thank you. Up by asking for time. So let's say it's 1%. And let's say your code runs for 100 seconds. That means that if you micro-optimize time down to taking almost nothing whatsoever, you have saved 1 second. That's the most you can ever get out of a gain out of that. The optimization is useless. Do not bother. Maybe 1% at your scale might actually save you millions of dollars. So maybe you should bother, but that's what you need to understand. And you probably already know about profilers and profiling first. But these are lies that are all over the internet everywhere. You'll have people benchmarking these tiny little things, and see something as small as 5% difference between two techniques and say, wow, I should use this one that's really obfuscated and harder to understand and is dangerous because it's faster. We can talk about what you're really benchmarking. Because, well, let's do Perl versus Java. Let's find out which one is faster. So you benchmark them and you find out that, wow, Perl took 20 BOGOs and Java took 10. I guess Java is way faster. But you did it on different operating systems with different CPUs, with different versions of the operating system. They're totally unequal. You're benchmarking 4 variables, and this is a useless benchmark. Worse, yeah?
So another thing is you obviously risk benchmarking just the benchmark, and then of course the hotspot compilable inline code because it's called a lot in this benchmark. Every time around the loop it's called, so we'll optimize component, and when you call it once,
Oh, yeah.
you don't see the inline optimized version anyway.
Mm-hmm. Yeah, you do run the risk of the optimizer being too smart or saying that, hey, you never use the return value of this function, so I'll just throw it away. Yeah. Fortunately, Perl isn't that smart. Java may be, but Perl isn't. The bigger problem than that, because most people know about that, is that when you say, hey, let's program Perl versus Java, let's throw some common programming problems at it. And, if a Java programmer writes the benchmarks and they write, hello world, like that, which is still horrifying, but it's what you do in Java. And then they go, okay, and I'll write the Perl code. Yeah, you don't do that. You just write print hello world. But you benchmark that code and you go, wow, Perl is really slow. Because what you're really benchmarking is whether they're a better Perl programmer versus a Java programmer. I really like the Debian Shootout, the language benchmark game, because they encourage people to submit the benchmarks. They say, here's the problem, here's the conditions, here's what the output we expect, here's the input, just write us some code, and we'll just throw them at all sorts of different kinds of hardware and compilers and versions of everything, and they have a huge matrix. But it gives the communities the chance to write their own benchmarks, and therefore you're actually testing the performance of the code as opposed to the programmer. And benchmarking just one variable. I have a joke in here about an astronomer, a physicist, and a mathematician on a train in Scotland. Does anybody know this one? Yeah? Okay, they're the astronomer, a physicist, and a mathematician on a train in Scotland, and they look out the window. And the astronomer, and they all see a black sheep. And the astronomer says, huh, that's amazing. All sheep in Scotland are black. Based on my observations. And the physicist goes, oh God, astronomers. No. There exists in Scotland a field which contains a black sheep. Please. And the mathematician goes, oh, save us from the physicist. There exists in Scotland a field which contains a sheep which is black on one side. Yeah. Thus ends the joke. Lies by micro-optimization related to the benchmarking lies. An example I have of this is somebody on Stack Overflow wanted a regular expression to parse these kind of log messages. Okay, fine. One of the answers was this, which is a pretty straightforward Perl regular expression. It has a few little issues in it, but it's totally unreadable. So you can do it with that horrifying mess, and it works. Another solution given was this, which is a somewhat less horrifying mess. But at least it's kind of, broken out and has comments and things like that and has pieces and whatever else. Now, it was presumed that this one was slower because it's more verbose. It compiles 2 regular expressions together, and it uses a feature called non-greedy matching, which for some reason people thought was slow. And it turns out that this one is actually faster. And it gets faster and faster as the log messages get longer and longer, which is surprising. And it's one of those things that after the fact, you can kind of work out why it's so. But takeaway is that Perl is really complicated. Any modern programming language is really complicated. Regular expression engines are scary, scary, complicated black magic. You are so far divorced from what's actually going on at the CPU level or anything that you can figure out that there's no way that you can look at this and just go, oh yeah, that one's going to be the faster because there are so many things going on in there. This little bit of code might translate into thousands and thousands and thousands of actual machine instructions, where the compiler could be doing things, the regular expression could be optimized for one thing and not for another. The compiler could be doing all sorts of clever things. In this case, it is. And you cannot predict the performance of a complex system just by looking at the code, unless you're him. And now I am at Google. He doesn't work here, right? No? Okay. Yeah. Let's see. I'm going to skip ahead because let's see what I've got left. Oh. This context? It's from Something Awful, Photoshop. What? It's not in my talk. It's my desktop background. I'm skipping through stuff. Nope, that's about it. Yeah. So, thanks. Any questions or anything else?
I had one comment. It's sort of related to the statistics that I think sometimes happens at Google, which is thinking that because you can measure something. So I had one comment that is sort of related to the statistics, which is people lying by measuring things and saying, I can measure this and you cannot measure whatever you're arguing for, hence we should do it this way. And I think sometimes we also fall to this trap. So examples are things like code health or user experience, which are not always easy to measure.
Yeah. Another example is sometimes I might say I benchmark the code and I say, oh look, the CPU utilization is, it's the CPU utilization says it should load in 2 seconds. And then you actually use the all-up, user interface, and you go, but it takes 20 seconds to load. And I go, oh, that's just, wall clock time. We can ignore that. That's all. Who knows what else is going on in there if what your CPU is doing. We can't trust that, but that's what really matters to the user. Fuzzy benchmarks and fuzzy statistics, especially like code health and code cleanliness, are hard. There was a project in Perl called CPANTS, the Comprehensive Perl Archive Network Testing System, which was a collection of tests over Perl code or Perl modules to test quality, spelled Kwalitee, because it looks like quality and it sounds like quality, but it's not actually quality. They were what we could measure that were things that were associated with quality code, but we weren't actually directly measuring quality code. In the kind of like, you can tell if somebody's going to have be a risk case for lung cancer by counting the ashtrays in their home. There's no actual direct relationship, but you can pretty well say that it's true. And these were things like, their README file, is their code well indented? How many global variables do they use? Such and such and such. Are they following these kind of community coding standards? And it was interesting. It kind of worked and it kind of didn't. But what it actually did is it turned things into a game. People would look at the CPANTS report for their module and they go, oh, I need to make that red light green. So it kind of became code achievements. And people would take old code that weren't following the newest standards, and they would fix it all up and upload a new version. And it was kind of good and kind of bad. It was kind of more educational. It didn't actually make the code any better in a lot of cases. But sometimes people went back through their old stuff and actually, in the process of making it look like it had quality, it actually improved the quality of it. But yeah, those are tough. Question?
No?
Yes.
I guess one of the things which I find to be the more interesting lies I find in code are the sort of lies by omission of not just documentation, but specifically when you see code and you look at it and think, oh, they're doing it the silly way. I can do this the right way. And maybe the silly way they've done it is because of some deeply subtle thing that they discovered over a very painful series of, tests and bugs and whatever. And they've just fixed it without putting in the comment saying why they're not doing the blatantly obvious thing that everyone who looks at that code thinks they should probably be doing.
Yeah.
Because they fixed this ultra subtle race condition. And I find the most valuable comments I see in code and that I try and make in code when I've come to the same sort of situation is, why didn't I do it the obvious looking way?
Yeah. Comments are most useful for why as opposed to
why and why not. People
Why not?
comment why they did something, but I want to know why they didn't do what I think is the obvious and better alternative.
Yeah.
And sometimes they didn't because they didn't see the alternative, and sometimes the alternative is subtly broken and you really have to not use it.
Yeah.
And that's the kind of stuff that for me makes great value in comments. I try not to comment what I'm doing. I try to comment, if necessary, why I'm not doing certain things.
Yeah. Yeah, the other way to prevent that or communicate that in a not necessarily in a way that is directly communicating it, but a way that will more directly prevent it from being removed is to test that edge case that you're doing that code for, so that if somebody comes along and says, "Oh, I'll just remove that," and then they run the unit test and it all blows up. But both of them are exactly what you want to do. You can say why not as well as why in comments. Anyone else? London? No? All right. Thank you.
Thanks, that was really good.
Thank you.
Two questions about the examples you used. One was